All right, guys, so what we're doing today is we are starting chapter 2. Today's first section, or first day of chapter 2. Now, chapter 2, unlike chapter 1, is going to mainly focus purely on quadratic functions. We're not going to jump around like we did in chapter 1 from different topics for each section. So, with chapter 2, we're talking and focusing on quadratic functions. Now, the first thing we're going to talk about is transformations. We've done transformations before. We've talked about them before, our up, down, left, right, stretch, shrink, and reflections. And we look at this here. K, if we have a value in place of K, it's telling us it's moving the function either up or down. H tells us we're going to move to the right or to the left. A tells us two things, one of two things. Either one, there's a reflection across the x-axis if it's negative, or two, if there's a vertical stretch or shrink. Now there is a third spot or a fourth spot, and I call it B in place of x between that x and the parenthesis. If we have a negative there, it's a reflection across the y-axis. If there's a value there, we have a horizontal stretch or shrink. Now the first few functions, we're going to mainly focus on horizontal translations and vertical translations. The value of h tells us how far we move to the left or right. If h, the value of h is positive, we move to the right. If the value of h is negative, we move to the left. K tells us how far we move up or down. If k is positive, we're going up. If k is negative, we go down. And let's look at these first few here. Now I'm going to write the general form each and every time. You don't have to. But again, I'm writing it so that we can see how A, B, H, and K line up. And if we look at this here, do we have a value other than 1 in place for A? Do we have a value for A? No. Do we have a value for B? Besides 1, no, we don't have a value there. But we do have a value for K. And the value of K is? It is 1. Would it be positive or negative? Negative 1. And we also have a value for H. Now the number for H is 4. Now would that 4 be positive 4 or negative 4? It would be negative. Because if we look at the general form, we don't have this B value. But inside that parentheses is x minus h. Yes? So for us to get that negative back, the only way that we can is if the value of h is negative. The only way we can go from x minus h to x plus 4 is if that value of h is negative. Because x minus negative 4, the negative and negative would make a positive. So really our value of h here is not positive 4, it is negative 4. That's the only way we could get the plus 4, is if h is negative. Okay. Now let's describe the transformation. So h tells us left or right. And since it's negative, it's going to the left. How far? 4. And the minus 1, negative 1 for K would be down 1. Left 4 and down 1. Questions on this here? Now this is a rigid motion, so we could just take this function, and every point on this function is going to move to the left 4 and down 1. So we should get a function that looks similar or close to this here. Now again, these transformations are good to have a picture of what it's doing, how it's changing, or how it's moving the graph. Especially when we start talking about solving, finding solutions for these here. Because when we solve a quadratic equation, we find the solutions, we're trying to find out what values of x will make the function equal 0, where it's going to cross the x-axis. And as this here, I move it left 1, down 2, I have a feeling, it's telling me that the solution should probably be negative, because that's where it's going to be crossing the x-axis. It gives us a picture of what the function should be doing. General form. Looking at this here, for this next one here, do we have a number in place of a? No. Do we have a number in place of k?
No.
Do we have a value for b? No, we don't have a number between x and the parenthesis, something taking b's spot. Do we have a value for h?
Yeah.
And that is, so it is 3. Now, would it be positive or negative? It would be positive 3, because x minus h, x minus 3. The x's line up, the negatives already line up, so h is positive 3. Almost. So indeed, it would be to the right. How far? Not quite. 3.
I think it was.
It would be right 3. That means every point on this graph would move 3 units to the right. Questions on this here? Are you ready for the next one? Do you have a value for A or B? No. Do we have a value for H?
Yeah.
And it is? 2. Would it be positive 2 or negative 2? Positive, because x minus h, x minus 2, it would indeed be positive 2. K's value is? Negative 2, because minus 2. So since h is positive 2, it's telling us we're moving where? Right 2. And down 2 for our k value of negative 2. So this here is right 2, down 2. So we move 2 units to the right and down 2. So we'd have a graph that looks something like this here. Questions on this here? And again, for the homework, I'm not going to ask you to graph it. I just want you to describe the transformation. Now, for the most part, we're not going to get a horizontal stretch or shrink and a horizontal translation in the same one. They interact weirdly. There's a weird interaction between the two. A and B, again, don't have a value. What's the value for K?
1.
Would it be positive or negative? Positive. H? Negative 5. Because again, when we look at this here, really what we have is x minus negative 5 squared plus 1. So our h value of negative 5 tells us we're moving where? Left 5 and? Up 1, yes. 5 and up 1. And that's it. Questions on this so far? Let's look at this last one here. There is no value of A, but H and K we do have, yes? H would be almost positive 1, because X minus H, X minus 1. So H would indeed be positive 1. K would be positive 2. So how are we moving here? Right 1 and up 2. Right 1 and up 2. That's it. Questions on this here? Reflections in the x-axis, reflection in the y-axis. So if there's a negative in place of A, if A's value is negative, it's a reflection in the x-axis. It's a reflection across the x-axis. Where I've been putting B, if there's a negative in front of the x, but after the parentheses, it's going to be a reflection across the y-axis. Now, for the most part, with our x squared, if we just reflect it across the y-axis, it doesn't tell us anything. Because x squared, this parent function, is considered to be an even function. It's reflected across the y-axis anyways. But if there is a negative in place of B, it's a reflection across the y-axis. If it's where A is at, outside the parentheses, it's across the x-axis. Vertical stretch or shrink. We'll look at horizontal in a second, but vertical stretch or shrink, we felt good with these before. If that number in place of A, if that value of A is greater than 1, it's a vertical stretch. If that value of A is between 0 and 1, it's a vertical shrink. If A's value is greater than 1, it's a stretch. If it's between 0 and 1, it's a shrink. We feel good with that there, yes? Horizontal stretch and shrink. Horizontal is a little bit weird. Now this here, this value of A, they're talking about the value that's in the function. Because if that value of A is between 0 and 1, we say that it's a horizontal stretch. However, when we go to describe it, we take whatever that value is and flip it. So they're saying if we have 1/7 in place of what they call A, it is between 0 and 1, so it is described as a horizontal stretch. But we wouldn't say it's a horizontal stretch of 1/7. We would say it's a horizontal stretch of 7. We flip it. Same as for the shrink. Because if, again, with the same example, if we said that we had 7 in place of A, it is greater than 1, so it would be a horizontal shrink. But we wouldn't say a horizontal shrink of 7, we would say a horizontal shrink of 1/7. We would flip it. So for this here, I feel it's easier, not easier, but I feel like it makes more sense for us to go on and flip that value. Whatever it is, flip it, and then describe it like we do with vertical stretch and shrink. Because once we flip it, it's going to line up with our greater than or less than. Let's look at this first one here. -1/2 x squared. So when looking at this here, are there parentheses for our function? No. So what that tells me is that there is no value for B or H. So there is no horizontal stretch or shrink. There's no reflection across the y-axis. There is no movement left or right. Is there a value for K? No. What is the only thing we have a value for? A, and it is -1/2. How many transformations do we have for this function? 2. Because the 1/2 tells us that there's a stretch or shrink vertically. The negative is talking about a what? Reflection. Because A is negative, we have a reflection. Across the x-axis. The negative is purely talking about the reflection. It has nothing to do with the vertical stretch or shrink. The negative is the reflection. Our value, the 1/2, is our stretch or shrink. So we'd also have a vertical. So 1/2, is it greater than 1 or between 0 and 1? Between 0 and 1, so it would be a vertical shrink of 1/2. I went too far. Yeah. 4. Yeah. It's kind of this more spread out. Questions on this here? So looking at this next one here, do we have a value for A? No. We have 1, but that doesn't really matter. Do we have a value for H?
No.
No. Do we have a value for K?
Yeah.
It is 1. Is it positive 1 or negative 1? Positive 1. Do we have a value for B?
Yeah.
2. But before we really start looking at it, I feel it's going to help us to just go on and flip it. So our value of B is 1/2, yes? Now, if this value B is greater than 1, the flipped value of B is greater than 1, it's a stretch. If the flipped value of B is between 0 and 1, it's a shrink. So our flipped value is 1/2. And because it is 1/2, it tells us that we have a horizontal what? Shrink of 1/2. Because it's not based off the original value, it's based off the flipped. Questions on this here? So we took that 2 and flipped it because the denominator is 1. So when we flip it, it becomes 1/2. If it was 1/2, when we flip it, it's going to become 2. K tells us we move up or down, and we're going to go how far? 1. This is a horizontal shrink of 1/2. So it's going to get skinnier and up 1. Now if I put this here on our graph and showed it, because 0, oh, it wouldn't be at 0, 0, we would move it up 1. Now since it's a horizontal shrink, it means it's going to be closer to the y-axis. It's not going to go as fast along the x-axis. And our next points would be there. And the point after that's actually just going to go up off the screen. Because our next point would be at 2, 17. So that's way off our graph. So it just got very skinny. It is a horizontal shrink by a factor of 1/2. We pulled it in. Questions on this here? Are you ready for the next one? So looking at this here, do we have a value for k? Do we have parentheses?
Yeah.
We have parentheses with g of x, but do we have a value for b or h? No, we have to have parentheses on that side. We don't have them. So that means there's no left or right, and there's no horizontal stretch or shrink, and there is no reflection across the y-axis. But we do have a value for a, which is -3. Now the negative tells me what? Reflection across the x-axis. And that's all the negative tells me. The 3, since it's in place of a, tells me that there's either a vertical stretch or a vertical shrink. It's a stretch if it's greater than 1. It's a shrink if it's between 0 and 1. Here, because it's greater than 1, it's a stretch of 3. So this would go down, and it's going to stretch by a factor of 3. So we get something that looks like this here. It's going to be skinnier. Questions on this one here? Excuse me. We ready for the next one? So for this one here, do we have a value for a? No. Do we have a value for k?
Yeah.
The value for k is -2. -2, yes. Do we have a value for h? No. Do we have a value for b? So it would be 1/4. But to really see that value of b, we have to flip it. Now b tells me, since I have a value there other than 1, that we have a horizontal stretch or a horizontal shrink. Because the flip value is greater than 1, we have a stretch. Of 4. And the k value of -2 tells us that we're going where? Down 2. Interestingly enough, if we plot this here, now it is going to move 0, 0 down 2, but the horizontal stretch of 4 says that our next 2 points are going to be here and here. So as we notice here, it's getting wider along the x-axis. We're getting farther away from the y-axis. So it is being stretched horizontally. But it's that, again, that flip of what we would expect it to be. Questions on this here? Bless you. Do we have a value for H or K? No. Do we have a value for A? The only value that we have is for B, because the value they gave us for B is 1/3, but the value that we're really going to look at is 3. Since it is taking the place of B, it's telling us that we have a horizontal stretch of 3. So we get something that looks like this here. Questions on this here? Get ready for the next one. Do we have a value of B?
No.
Do we have a value for K?
No.
Do we have a value for H? Because the number is 1, but would it be positive 1 or negative 1? It would be positive. And our value for A is 3. Now, since A is positive, we do not have a reflection across the x-axis. But the 3 does tell us that we have a vertical stretch or vertical shrink. Stretch, because it is bigger than 1. And H tells us we move to the left or to the right. Since it's positive, we're going to move to the right how far? Almost 1, because H is positive 1. Questions on this here? We ready for the next one? Looking at this here, do we have a value for K?
Yeah.
And it is
2.
2. Would it be positive 2 or negative 2?
Positive.
It would be positive. Do we have a value for H? And it would indeed be negative 3, because really what we have inside this parentheses here is x minus negative 3. Do we have a value for B? Well, we do have a value for A. Well, not so much a value, but we do have the negative, yes? The negative for A tells me that there is a reflection across the x-axis. H being negative 3 tells me that we're moving left 3, and our K value tells we move where? Up 2. And that's it. Questions on any of this here? All right. We're going to do the last bit tomorrow. I'm going to go on and show you the homework assignments. 3 through 11 odd, 17 through 21 odd, 27 through 29, and 31 and 33. So 27 through 29, we'll still need to finish the other part with identifying the vertex, but we will get to it here in a bit.